Good morning, everyone. Welcome to this session of ETMD. I am Giang and Professor Chia-Ming Pham is the chairman of this section. So today we will research into three topics. One is civil engineering. The second one is water resources. And the last one is transportation engineering. Just waiting maybe 5 minutes for Professor Huynh Trong-Phuoc. Yes. So maybe we would like to invite
maybe we can change the order of first and second speaker. So, Professor Shih, you're welcome. Okay, the speaker is Professor Shih. He's a chairman of from Department of Harbor and River Engineering. And in our department, he's belong to the division of coastal engineering, ocean engineering. So later he will make a presentation about the experimental study of ocean engineering related issues. Okay, let's welcome the speaker, Professor Ruey.
Hi, good morning, everybody. It's very happy to join the conference in Vietnam. This is my second time to visit Vietnam. And we have met the third time. The first time they went to Taiwan or Ocean University. So today I'm going to talk something about the experimental study because in my expertise is all the study about using numerical method, using wave basing and wave flume. And today I will introduce something more special because they're very interesting nowadays because it's easy to be done nowadays. It's very difficult to be done in the past. So the fact that the method is you use the EPIB to study the velocity distribution around the air and water interface with respect of wave breaking in the coastal region. So here's my content, the introduction, experiment setup, the result and discussion, and finally the conclusions. So how are we going to study this issue? Because it plays a very important role in the coastal area because when we went to the coastal area, we can see many waves, great wave breaking, but there are plenty of study concerning wave breaking of how the interaction, how their velocity distribution, but only in water area instead of the fluid on the air. Now it is impossible to measure the velocity distribution in past, but nowadays it's very much easier to investigate, to study the velocity distribution on the air in the interface of the water surface. So here, because the highly turbulent and multi-phase flow problems in the gas region caused by the wave breaking is very closely related to the coastal erosion, the change of the coastline, and the coastal protection. The other is tensions interaction between the water surface and air during the wave breaking and wave process in the coastal area is extremely complex because you can use numerical modeling like Professor Pham. They can easily modeling the distribution of the velocity, but it is very hard to measure by using some instrument in our physical experiment because it's invisible. You can't see anything, just like water. But nowadays you can detect, you can easily measure without using some instrument like ADV because we have to place the measurement instrument into the water. they will disturb the water. So the things you measure is not exactly truth, it's not exactly the value. And in other words, you place the ADB measurement instrument into the water, you can only measure one point in the time series, just like a wave gauge. You can't measure the full area of the distribution simultaneously with the water and the air. So you can see this are the figures, all the figures that I have done. This was not present, this was not public yet, because you can see the investigation in my laboratory. This investigation was under construction in the preparation to submit into some kind of journal, but it hasn't published yet. So you can see maybe this is some kind of secret in my investigation, because no other papers you can find in the world can have the same result as I have done. So this study intends to quantify the velocity distribution on both water and waves and gas simultaneously in the same time, not separately, by using the PIV method, and also interaction. The water-gas velocity field problem is the wave breaking process, and it's very important. So let's take a look at our wave flume. Because we use the PIV technique, so we don't need a very large wave flume because it's very hard doing so. So we construct the experiment only in a flume, only 5 meters, something like an open channel flow in our flume laboratory. So the width of this flume is only 15 centimeters, and we place a this laser to this area to film. And this is a camera of a high-speed camera of Sony. We can't done this before because it is very high cost of a high-speed camera. But I found a camera of Sony. It costs only 30,000 NT dollars, about lower than 1,000 US dollar. So it's feasible for us to study this kind of questions by using this camera. We can shot the film for 1 second, about 960 film. So it is enough for us to study in our ocean, in our wave mechanics. So this is what we've done. And as a classification of wave breaking in the coastal area, mostly you can find in most of the textbooks, they have classified all the breaking into three kinds. The first one is the spilling, and the second one is plunging. The third one is surging. Somebody will place another collapsing between plunging and surging, but in this study we just studied the spilling, plunging, and surging, 3 kinds of wave breaking. And this is the European number of how to judge, how to separate all these kind of wave breaking. So in our laboratory, we also have to follow the rule. So this is the conditions that we have done in our laboratory, in our wave flume with different slope, and other conditions. So we make sure that the European number must fit the condition of all these kind of wave breaking, so we can create the 3 kind of different wave breaking. This is the measurement of the gauge we place in the film, how the wave goes. And we can see how we use the PIV. The PIV actually it's very hard to find the tracing particle. In the past, they used to treat it as a top secret because they don't tell you what they use. You have to find it yourself. In the old time, they used some metal. They have to cook to temperature, let the density of the particle very close to the density of the water. And it's also very difficult for me too. But finally, I found some kind of particle that the density is about 0. Specific gravity is about 0.992 or 91. It's very close to the water, so it still will float on the water, but actually it doesn't float that fast and it doesn't sink. So we can use the particle for the experiment. And in our PIV analysis equipment, we use some kind of open source. They can easily analyze all the velocity. But actually, because the particle is very small, you can't trace all the particles by each particle. You know, the particle is very small. The diameter is very small. So actually, theoretically, they don't trace each particle. They just separate into a block, and they trace the block, the variation of the block into this stage to this stage with the delta t times the disturbance, and they can find the velocity by doing this, by comparing these two frames together to see how it changed. So they can find the velocity distribution in each time step. So this is what they do to do the analysis. So here I will go into the result and discussion with the spinning breaker, the surging breaker, and let's see the plunging breaker. These three topics, we will see the distribution of the velocity, how they behave, and how they're alike. And finally, we will conclude the first one, the second one, and the third one. We compare all together. The variation of kinematic energy, because we have the velocity distribution, so we can calculate the kinematic energy of the region, including the water area and the air area, to see how they behave in their braking procedure, because it is not easily done before. As far as I'm concerned, there are no paper published yet. So let's take a look. This is the film that let's take a look. Sorry, I can't find the error. So this is the process of the breaking wave of the spinning breaker. You can see the distribution of all the velocity distribution, including in water and also in this interface around the air around the interface. So you can see that we have measured all the velocity distribution simultaneously with air and water at the same time without separation. So also how can we can analyze it. This is the water area. Water area, most of the paper, including numerically and physically, they can do this very easily. They are using worldwide. Everybody study the particle velocity in the water. But at the same time, we can see also the air, the distribution. I have seen a paper, very last paper, concerning about the air distribution. They found that there has a rotation, some vortex on the top of the water, but they can prove by using experimentally, they can prove anything. So now I can prove the velocity distribution, not only using the numerical solution, but also the physical experiment. So this is what we have found, the velocity distribution in our in the water area and the air area. So we can use the velocity to calculate the kinematic energy, because it is not easily done in the past, because they use the wave gauge to measure the wave elevation. They can only calculate the power of potential energy, but they can measure the velocity. So it's very, very hard for them to calculate the kinematic energy. Nowadays, I can calculate the kinematic energy in the water and also the air. So let's take a look at another case. This is a surging wave breakwater. So you can find all the distribution in the air into the interface, and also around the air area and the water. There's a little bit of rotation in here in the beginning, and also a rotation inside the wave fluid. So this is what we have done in our laboratory. And finally, I separate the air and water into two figures. We can see the distribution in the air and also in the water, and we can compare all this together. And finally, we can combine all these together into a photo. So we can see the breaking procedure, all the distribution, all the variation of the distribution. Also, we can calculate the kinematic energy, and we can see if there's any transmission between the water and the energy between the water, because many people think that there are a part of energy that is transferred into the air, because the air the velocity on the air is still in the beginning, but after the wave had breaking, there were it caused many large vortices on the air. And how the power come from? They think that it come from the water wave, but they can't prove it. However, due to the density of the water and the air's density is much smaller than the water. So although we can calculate the density, but the translation between the air and the water, I think is only a very slight, very small power. So here's the third one. The third one is the most famous one, plunging wave breaker. Because we have a tongue in the end, and this is very high tech. So we can find the rotation here and also the rotation around on the place. So we then have some. I only find one or two papers that concerned about there exists a rotation on the surface of the wave breaking, but they can't prove it. They use some kind of smoke. They put the smoke on the air and they see the rotation, but they can measure the velocity. They can the data. They get the data. Now I can get the data. So you can see here's the water in the water interface, and here's also on the air. You can see the procedure of the plunging wave breaker is very beautiful. It's very beautiful, but it is no good for the coastal area because it will cause a very large erosion. It will cause a very large transmission of the transportation of the sand. So many people try to eliminate the energy of the wave breaking to protect the coastal area. So there's another issue I'm working out. I'm designing many kind of breakwater to dissipate the wave energy. But most of the wave, as I told the students, you can find many papers, many kinds of design in the breakwater, hundreds of breakwaters, but most of the over 90% or higher of the wave breaking structures only dissipate the waves with smaller wavelengths and intermediate wavelengths, but they can't do anything to the long waves. And now in my laboratory, I'm trying to let my students to use something related to the air pressure, to release the air pressure on the surface if they can change the phase angle, the phase between the incoming wave and the transmitting wave, and to see how the effective of the dissipation of long wave. And our purpose is to dissipate long wave, not intermediate wave and short wave, because you can be done very easily by other structures. But in the world nowadays, it is very difficult to dissipate a long wave energy. So this is what we are working on. Maybe in the future, before I retire. Okay. So this is the distribution of the wave, the wave breaking procedure. Okay. This is the fourth one. So I calculate all the kinematic energy on this is in the water area, and this is the air area using the velocity distribution in the whole area. Okay. Here is in the water area. Here's the as I said, because their density is very different, quite different, and so they have we can see what the relationship between these two kind of power. Each node means each time step. The procedure from breaking began until the breaking is done. The breaking procedure. Each node represent a time step. So I separate a procedure into 10 time steps to calculate. So you can see the figures for time step, and we calculate all the result. So finally, the conclusion is that it is difficult in the past to use PFD to measure the velocity distribution, but we are trying now to present a new one. So maybe here's the conclusion. You can see yourself. You can see all in our figure. So that's for our presentation today. Thank you.
Thank you, Professor Shih. Any questions? We can have a quick question. Okay. You know, we can discuss with professors.
Everybody who is interested in physical experiment can join us.
Okay, thanks, professors, again.
Thank you very much, Professor Ruey, for really interesting topic about the dynamic behavior of the wave, especially for cost ratio. So the next one is Professor. I would like to introduce you, Professor Trong-Phuoc Huynh. His topic about recycled material. Okay, please welcome him. Join me to welcome him. Presentation. Okay, thank you.
Okay, ladies and gentlemen, good morning. Today it's my pleasure to introduce you guys one topic about the construction material. Actually, we did a lot of experiment based on the recycling of different kind of industrial and agricultural byproduct. So today I'm going to introduce about the recycling of used stuff to ground to make a lightweight composite for the lightweight structure and also for the non-loss-bearing lightweight composite. Like especially in the MEKONG Delta region, because the foundation in this area is not so strong compared to other areas, so it's very special material. Today, I'm going to introduce about the way how to recycling the used stuff in ground is a waste material into the fire aggregate to replace the natural sand. Let me see how to move. It's not working at all. So from the industrial activity and also from the agricultural activity, they raise for the industrial and for the construction material many issues. First of all, I would like to mention about the CO2 emission, because from the construction material we use mostly cement, and cement industry produce a lot of harmful gas. For example, to produce 1 ton of cement, we can see that they consume about 110 electricity and also fuel and release about 1 ton of CO2. So one question raised for us to try to reduce cement, and we have another way to reduce cement. Later I will mention about this. The other thing is you can see that from many activity they release a lot of waste product, and actually some of waste product we can recycle to be good material for construction material. And the other thing is you can see that here some very common construction material like fly ash is a waste material caused industry, and also another thing is slag and silica film and other dry ash. All of them are the waste product from other activity, and we can use as a byproduct to replace the cement in the production of green material. We can say that based on this polychloride reaction is the foundation for recycling of like the polychloride material. For example, fly ash, dry ash, and other material as I mentioned before, is based on the polychloride reaction, and it can make the chemical reaction inside the mixture, and it can be placed in a new cement, and it's combined all the fire aggregate to be a solid material placed in the cement or mortar or something like that. And we can use that kind of material to build the building instead of concrete, traditional concrete. And especially in the MEKONG Delta region, we can see that recently we don't have too much sand, natural sand. And we try to find a way to find another material to be placed in the construction activity. We can see that used coffee ground is one of the byproduct. It's available in the large amount in the Vietnam. You can see each kilogram of coffee ground we can use to produce almost 2 kilograms of used coffee ground. So the consumption of more coffee in Vietnam and other countries in the world, we can see that a lot of waste product can generate, and all of this product we can recycle to be the material to be placed natural sand like that. This one, this is the coffee ground in Vietnam. My student collected from many restaurants and coffee shop or something else. We combine together and have the pre-treatment method to be the material like that, and then we can reuse. The next one, maybe I will give this one. We don't have much time. The recycling procedure. You can see in this activity we make the alkali activated material. This means no cement, mortar. We use fly ash together with slag, with some alkali solution like sodium hydroxide, sodium silicate mixed together to create the new cement. And then for the fire aggregate, we use bottom ash also waste product from the forced thermal power plant together with used coffee ground to be a mixture of fire aggregate and mix together to form the composite. Is the lightweight one, because you can see that the density of this material is very light, much lighter than sand. So we can make this very light composite and use for like the wall non-bearing, other non-bearing composites. Here we can see this part of the microstructure of the used coffee ground like this one. You can see it's a lot of like the hollow and the pore inside is very light one. So we introduce it into the composite to be the lightweight aggregate. And here the mixture proportion, I tried some different mixture proportion in the laboratory. You can see that with no cement. It's basically one, no cement. This one like the alkali activated cement together. And we can see some result. Here's some of the experimental result and experimental test in the laboratory. In this study, we just show the data up to 28 days because it's based on the national standard to see whether it can be used as a construction material or not. Here, the first one about the dry density, we can see that because the structure of the used coffee ground is very, very light, and this comprises a lot of pore inside. So when we introduce it into the composite with the increased amount, the density is reduced too much, and all of them are classified as a lightweight material based on the national standard in Vietnam. The other thing is also we can see that with the optimal content, the strength can be improved, but further increase the content, we can see the strength reduce a lot. Significantly can reduce. So based on the result, we can see that about 10 or 5% replacement by volume, we can see the result is improved. It's not only based on the photodynamic reaction, also based on the Fuller reaction, because some particle of used coffee ground is very fine, finer than sand. So we mix together this like a Fuller to fill the structure. So that's why about 5% of replacement by volume can increase the strength a little bit. The other result here about the rising breakage is very important factor to use as a construction material. We can see that when we use used coffee ground to be placed in natural sand, the rising breakage reduced significantly compared to the original one. It's been used the natural sand because the breakage is very high. We can see there are 3 reasons I can mention. First of all, is about the particle of the used coffee ground is irregular shape, and it makes a good interlocking inside the structure. So it's improved and it restricts the movement of the particle inside the structure. So it can reduce the rising breakage. Another one is about this one, the internal curing effect. It's been because the lightweight structure, so it absorbs a lot of water, and when we mix inside the mixture, it keep the water inside. Later on, during the aeration, it release the water, so it can retain the water and moisture inside the structure. That's why it can prevent the dry breakage significantly. The other thing is about the filler effect. It means we can use the Yu-Jia to replace the PA, means bottom edge. So the radiation of the aggregate becomes better. It means that inside the structure we can reduce the pore volume, and so it reduces the dry breakage. This behavior is very important for the preparation of lightweight material using waste product. It's much compared to the original one. And about the water absorption, it's similar strain like the convective strain because it's very light. So it's a soft water. You can see it's a soft, much water. This is one of the drawbacks of using used coffee ground. So that's why I suggest about 5 to 10% we consider for using to replace natural sand in the production of lightweight composite used in the construction activity. For the application, we can see that most of the applications of used coffee ground in the world, they use for like agricultural products. We cannot see much recent paper about the recycling of used coffee ground in construction material, but we can find one. Some of them like the brick, block, or something like panel, something like that, but not much. From the result of this study, we can suggest that we can use about 5 to 10% of used coffee ground. With the strain, you can see that satisfy the requirement for the national standard in Vietnam. But I believe with the result, it's also satisfy some standard from the US or something UK about the view of used coffee ground for making the lightweight composite, especially for non-lock bearing composite. About the dry breakage also. So this study we can consider as a reference for someone who want to apply this model to use for recycling of other material like with the structure like underground, like the used coffee ground, and it's very helpful for students also. They want to be referent to get the idea to recycling, and also the recycling of waste product is one of the hot trend in most of the countries in the world, especially in Vietnam in the future. So that's all for the presentation. If you guys have any questions, please. Thank you.
Any question? I encourage my student to at least some question. Dr. Tri.
Thank you, Professor Phuc. Yeah, this is a very interesting presentation. Yeah, and when you're talking about the coffee bean, I am a little bit curious because this is organic material, right? So if you put it into a concrete for a long time operation, do we have any chemical reaction, or does they have something like chemical change for the coffee bean?
Okay, thank you. It's a very good question. Actually, there's a secret here, but I speak very fast. If we want to recycle this kind of material, we need to have reducement method. Otherwise, we cannot be used because it's like organic material and it will not stable inside the structure for a long time. So actually in my laboratory we have some different method to refresh this one before using. But in that time we keep this in a secret. Later we will write some paper or some patent about this one. Yeah, we have retreatment, and you can see that if we want to recycle that kind of material as like a useful material, we have several ways to retreat this one. We can see from the internet or some paper. But I have tried that before, but most of them not have a good efficient result. We combine a lot of things inside, and right now it's on the way to try, and we almost find a good result about the treatment methods. Sorry, I want to keep it a secret now. That's why that slide I do not talk too much about it one. We try a lot of different because that's very difficult to be reduced, not easy. Thank you very much.
Who else? Okay, thank you very much. This topic really interesting. You know, Mekong Delta, we have some power plant like Long-Phuoc, Ô-Môn, Duyên-Hải. So it's really effective if we can solve some challenges in this Mekong Delta roaming. Thank you very much. The next one, I would like to invite I would like to invite Mr. Nguyen Phuc talking about the simulation of the low velocity change in the Cái Khế channel during operation of the Cái Khế slip gate.
Xin chào quý thầy cô và cùng tất cả các bạn. Em xin báo cáo về đề tài mô phỏng vận tốc dòng chảy trên kênh Cái Khế và đoạn thẳng Cái Khế. Thì trong quá trình đô thị hóa và phát triển của thành phố Cần Thơ thì nó xảy ra cái tình trạng là úng kéo dài. Thì trong các cái đề xuất để mà giảm ngập thì trong đó là có xây dựng kè và đê, và trong đó thì có xây dựng các cái cống. Thì trong quá trình xây dựng các cái cống này thì nó cũng có tiềm ẩn những cái nguy cơ gọi là nó có hạn dòng chảy, làm tăng dòng tốc dòng chảy cục bộ ở vị trí của cống. Thì đề tài nghiên cứu về mô phỏng dòng chảy qua cống tại cống Cái Kế, thành phố Cần Thơ. Về phương pháp nghiên cứu thì anh tổng hợp các cái số liệu về số liệu sơ cấp và số liệu thứ cấp. Thì số liệu sơ cấp gồm có đo đạt dòng chảy tại cống và lấy mẫu vùng cát, sau đó là phân tích dữ liệu và setup mô hình. Thì sau khi xây dựng được mô hình đó, thì có kiểm định và hiệu chỉnh lại mô hình và mô phỏng các cái kịch bản mà vận hành khi mà cái cửa van nó mở ra thì dòng chảy sẽ thay đổi như thế nào, và tiến hành đánh giá số lệch. Về số liệu thứ cấp thì gồm có bản vẽ về công trình và các cái số liệu về cao độ và đồng đồ của khu vực. Thì về đo vận tốc dòng chảy thì có đo tại vị trí số 1, số 2 và số 3. Khi lấy mẫu vùng cát thì lấy mẫu vùng cát tại vị trí số 1 cách cống 10 m, cách cống 60 m và cách cống 110 m. Trong quá trình mình đo đạt dòng chảy thì cũng có đo thêm mặt cắt vận tốc dòng chảy tại cái vị trí này để mình xác định điều kiện biên của mô hình. Về thiết bị đo đạt dòng chảy thì em đo đạt bằng thiết bị VDAC SCM kết hợp với máy đo độ sâu Hornet để và cái level G để khi mình xác định được vị trí khi mà quá trình mình đo đạt. Về lấy mẫu vùng cát thì em lấy mẫu 3 mẫu. Mỗi mẫu thì lấy tại cái vị trí tim cống và các cống theo cái sơ đồ. Thì mẫu vùng cát sau khi thu thập xong thì tiến hành thí nghiệm về gây khô và thí nghiệm về tự trọng kế. Khi xây dựng mô hình thì gồm các xây dựng mô hình civil 3D. Sau đó mô hình civil xây dựng gồm có những cái về làm dẫn và cái thang cống, và sau đó được đưa vào mô hình flow 3D để set up các cái điều kiện về vật lý. Sau đó sẽ được xây dựng cái kịch bản vận hành cống. Về hiệu chỉnh mô hình thì em hiệu chỉnh là thông qua cái hệ số nhám của thang cống và hệ số nhám của lòng dẫn, và kiểm tra qua cái hệ số NSA. Khi kiểm định mô hình thì kiểm định thông qua cái hệ số NSA và có kiểm tra lại cái hệ số nhám của cống thông qua các cái tiêu chuẩn của Việt Nam xem nó có phù hợp hay chưa. Về kết quả đo đạt dòng chảy tại 3 cửa cống thì tại cửa số 1 là cái vận tốc dòng chảy nó thấp nhất, và tại cửa số 3 thì vận tốc dòng chảy nó cao nhất, nó hơn 0,3 m trên giây. Về kết quả phân tích cái thành phần thể hạt của mẫu vùng cát đá thì có được cái đường cong cấp khối hạt. Thì dựa vào đường cong cấp khối hạt này mình có thể xác định được cái D50 của sau khi tính toán và xây dựng mô hình thì mình sẽ có cái kết quả về hiệu chỉnh mô hình. Khi em hiệu chỉnh tại cái cửa số 1 thì có NSE bằng 0,74 thì nó cũng khá cao, nó gần bằng 1. cái mô hình này cũng khá đáng tin cậy. Sau khi điều chỉnh xong mô hình thì sẽ tiến hành là kiểm định mô hình tại cái cửa số 3 và NSE bằng 0,61 thì hệ số này cũng tương đối cao và mô hình mình cũng khá ổn định. Về kết quả mô phỏng thì mình có 3 trường hợp. Là thứ nhất là khi cửa van bắt đầu mở, cửa van mở một phần và cửa van mở hoàn toàn, thì nhận thấy khi mà cửa van nó mở một phần thì vận tốc dòng chảy tại vị trí phía dưới cửa van thì nó sẽ tăng cao, và nó ở phía trên thì nó sẽ bị dòng chảy nó xảy ra cái sự cuộn xoáy tròn. Thì khi vận tốc khi cửa van nó mở ra một phần thì vận tốc dòng chảy nó giảm dần và nó đẩy vận tốc dòng chảy về phía hạ lưu nó tăng cao lên. Thì khi mà cửa van nó mở ra hoàn toàn thì vận tốc tại vị trí cửa van thì nó ổn định lại và nó tăng cao ở hạ lưu. Thì tại có xuất ra được kết quả của 3 đi trực. Tại đi trực số 1 thì vận tốc dòng chảy nó lớn hơn 3 mét trên giây. Tại đi trực 3 thì nó lên đến 4,5 mét trên giây. Nhưng khi mà xét về cái điều kiện là vận tốc trong sói thì là từ 0,19 mét trên giây đến 0,26 mét trên giây. Nhưng vận tốc gần tại đáy thì nó đã lớn hơn là 2 mét trên giây, thì từ đó cái lòng dẫn của mình nó có xảy ra nguy cơ xói lở. Về kết luận thì các cái điều kiện về thủy lượng thủy văn và các cái số liệu về vận tốc và các hàm lượng bụi cát đã được thu thập và phân tích. Về mô hình thì mô hình cũng đã được xây dựng với hệ số NSE trong cái trường hợp hiện chỉnh là 0,74 và trong trường hợp kiểm định là 0,61, và mô hình được xây dựng với hệ số nhám than cống là 0,15 và của đồng dẫn là 0,3. Về khi mà em mô phỏng các cái cửa van vận hành thì vận tốc trong sói là từ 0,19 mét trên giây đến 0,26 mét trên giây, và khi chạy ra được thì từ vận tốc lớn từ 2,97 mét trên giây đến 4,34 mét trên giây, thì từ đó kết luận là cái lọc dẫn mình nó bị xói lở. Bài báo cáo em xin hết.
Question? Chiu-Ming. Cho hỏi cái phần chiếu là cái slide cái cuối đó là cái chỗ mà cái slide gì đấy trước. Ok, vậy thì cuối cùng đó là cái từ cái kết quả này là kết quả tính toán từ cái mẫu, đúng không? Rồi, vậy thì có ra kiểm tra thực tế là có như thế nào trong cái lòng dẫn
Về cái vị trí vận chảy của sói là tại vì là cái cắm mới vừa sau cái chú đó là còn nó bị sói
thì đi có kiểm tra rồi cái giá trị hỏi luôn cái giá trị này như vậy có đề xuất là có nguy cơ, đúng không?
Dạ.
Dựa trên cơ sở nào để việc nó có nguy cơ xoay lở?
Dạ, dựa vào nguy cơ là cái vận tốc trong sói cái nhập tốc khi mà mình mô phỏng mình mô hình chạy ra thì nó từ 0,97 mét trên giây cho đến 4,34 mét trên giây.
Thì theo em thì chỉ có lấy độ tốc thôi là có thể kết luận rằng nó có khả năng hút cái động lực.
Cái phương pháp nghiên cứu của em thì chắc là chiết xuất được có 3 tiêu chuẩn thôi, tại vì 3 cũng chưa phải thực tế được cái mọi vị trí trên cái mặt trận đó.
Cái sở như vậy thì cái phần này tại vì nếu mà làm dẫn nó sẽ nguy cơ sói là nhiều yếu tố nó chưa được tính kể tới cái địa hình, đúng không? Nên một thì đây là tính mô phỏng đưa ra hai rồi các yếu tố khác để dẫn dắt ra cái kết luận đó là chỉ có dựa trên mô hình, chỉ xét cái yếu tố là cái vận động lý hạn chế cái nó sẽ làm cho sự còn nhiều nguyên nhân khác đúng không? Okay, thank you very much. Very interesting topic. The next one is okay. Okay, the next one is I would like to invite Mr. Hoang-Trung-Hieu. Okay, he will share about the effect of the limestone power particle size contact on the cement paste. Surprising.
Good morning, Professor Tỉ. Good morning, Professor Giang and Professor Pham and other professors from Taiwan Ocean University. So my name is Hieu, and I'm very pleased to be here to share with all of you about our research, the effect of the limestone powder particle size that contain on the Portland cement paste. So firstly, I'm going to introduce our research group. So this research was conducted in National Central University, Giang, Taiwan, and this is our professor, very lovely professor. And after graduate, I go to this university for my teaching career. And about the research, I will talk with all of you briefly about the reason why we need to use limestone powder in cement, and our material research method and result discussion and conclusion. So firstly, for the introduction, it's quite similar to some eco-friendly research. So the key point of the concrete production nowadays is that we are trying to reduce the carbon dioxide emission. So normally you can see that if you produce Portland cement, we will have a lot of carbon dioxide emission. So our target is that we want to use limestone to replace cement. So it can help us to reduce the carbon dioxide emission. And the reason why we use limestone, because in Taiwan, limestone is very easy to get. So you can buy limestone everywhere, and even for the global, from other foreign companies. And besides, limestone is very easy for grinding. And for the supplies in Taiwan, you have about approximately 800 metric tons per year. So we have a lot of huge demand, so we can use this in to replace the Portland cement. So according to our research, in 2023, using the limestone Portland cement have some advantage, like you can reduce the carbon emission, have sustainable solution, global in nature, and enhance the cement performance. However, it comes with some disadvantages, like not many research focus on the limestone powder using in cement, and we are not very sure about the quality or the potential performance, as well as there are not many standards to guide us how to use the limestone in cement. So we conducted some standard. We have here a European standard and Taiwan standard and American standard, and they give us some percentage of the limestone addition in to replace cement. So we will have from 0 to 40%. So the maximum replacement percentage will be 35% according to European standard. And the mechanism of limestone, when we use it to replace cement, it can be used like fueler. So we know fueler is something you put it and make concrete denser. And move to the next slide. And for the nucleation, when we push limestone into the cement, it will be a kind of foundation for the CSS gel to connect into the limestone, and it can develop more efficiency than the traditional Portland cement. However, we will have some limitation like the dilution. So the more we put limestone in cement, it will not have chemical reaction, so it will reduce the compressive strength of the cement test when we put a huge amount. And the chemical reaction, according to a literature review, they say that if you use limestone, it can react with the aluminum oxide to form the aluminum carbonate salt. And this chemical can help the concrete more stable and increase the durability. So this is our material and our research method. In order to evaluate the particle size and the volume, we will separate our limestone powder into 3 different categories. The first one is the pore size. So you can see that the specific surface area will increase. We will use it as a fueler, so we replace the cement test inside we will replace cement inside the cement test. And this is the average size of the limestone powder. We will have 3 different kinds, the coarse aggregate, the medium size, and the fine limestone powder. And according to ASTM standard, Canadian, Taiwan, Australian standard, so we will replace 5, 10, 50, 20, and 40%. And we use different 3 types of the limestone powder. So this is just a fundamental experiment. So we do some quick investigation first for the flow test and the compressive strength. And the flow test was conducted according to STM C230. And for the compressive strength, we will evaluate the compressive strength of the cement test after 3, 7, and 28 days. This is the size of the cement test. For the XRD analysis, we will use the XRD machine and the information, input information like in this slide. For the regression analysis, so in this case, because we want to evaluate the particle size, but if we do the sewing, the particle size of the limestone powder is very fine. We cannot do the sewing. So we will use some regression analysis like this equation. This was conducted according to Ben's research in 2013. So we do 50-50 contour plot and using MATLAB equation, and then we will plot the figure. So this is our result. This is a little bit complicated, so I will introduce for you guys. Firstly, this is the particle size for the 5 aggregate. You can see from 0 to 10 micron. And for the coarse limestone powder, it's from 15 to 30 micron. And after doing the experiment for the slope flow, replace from 0 to 40%, then we will put the data into the equation and using MATLAB, and if you calculate the slope value, and this is the slope of the slope value. So if we choose the 10 micron and then replace with 10%, we will have the slope flow about 120 to 125%. So the conclusion for the first one is the fine limestone powder is that if we replace Portland cement with coarse limestone powder, the higher content, the better workability we can achieve. So for every 5% increase in the content, we will have the workability will improve about 4%. And the next one for the fine limestone powder, the more we increase the fine limestone powder content, the lower workability we will achieve. So the reason behind that is because fine limestone powder, if you have very high specific surface area, so it will trap the water molecules inside the cement pads, so it will reduce the workability of our cement pad. For the compressive strength of the limestone powder, so this is the particle size and this is the limestone content, and the percentage over here is the relative compressive strength in after 3 days. So we will calculate the percentage according to the control sample. The control sample will be 100% of Portland cement. So the result simply is that the more we replace the limestone powder in cement pads, the lower compressive strength we will achieve. And there's one more findings. If we use the fine limestone powder, we will have higher compressive strength than the coarse limestone powder. And this is our result. If we replace 50%, we will have the compressive strength over than 78%, 20%, 70%, and if we replace maximum 35%, we will have the compressive strength only 55%. And this is the relative compressive strength after 7 days of curing. And because of the dilution effect, when we mix more limestone powder, we will reduce the hydration products. So the compressive strength will reduce, and it reduces significantly after 7 days of curing. Besides, if we use the fine aggregate, the compressive strength will still maintain about 75%. And the same in 28 days, the more we increase the limestone content, the higher compressive strength we will achieve. However, the finer limestone powder will give us higher compressive strength compared to the coarse aggregate. And this is our XRD analysis. So the XRD analysis will have two main things. The first one is the MC. MC value over here. The pickup and MC over here is represent the aluminum carbonate chemical. So the purpose of using the limestone powder, it will react with the aluminum oxide inside the cement and form more stable chemical compared to the traditional Portland cement. So we can see that the more we use fine limestone powder, the higher peak of the MC over here, you can see in the XRD analysis below. So this means that we will have more hydration product, and the peak of the CH, this is the Portland dye component. So it means that if you use fine limestone powder, we will have higher cementous hydration compared to the coarse side of limestone powder. Yeah, so this is our conclusion about using the limestone powder on the cement pads. So the key point of this one is that the finer particle size can and increase the doses can reduce the workability, because when you use finer limestone powder, it can trap the water inside it, and it will reduce the workability of the cement pads. And the content of the limestone powder, when it less than 50%, the effect of the limestone particle size on the compressive strength and workability is insignificant. So if you use less than 50%, so the quality can be controlled compared to the control. And when the addition less than 50%, for each 5 to 10% compressive strength decrease, we can increase about 5% of the limestone powder content. And the smaller particle size of the limestone powder can increase the nucleation and the chemical effect, and it can increase the compressive strength of the sample. So this is our reference for this research, and this is the end of my presentation. Thank you very much for listening.
Any question? Professor?
Yes, thank you, Professor for the question. Because this one is actually just a fundamental experiment, so we want to do some investigation to have the deeper knowledge about the purpose of using limestone to replace cement. So the key point of using limestone is still the quality, right? So the quality involves the mechanical properties. So we have compressive strength. So we will focus on the fine limestone powder, even though it will reduce our workability. And the percentage for the replacement is around 15% only, because if we reach over than 50% replacement dosage, then it will strongly reduce the compressive strength. Thank you, Professor.
So let me ask a question. Actually, did you consider about the risk of diversion after you ask the limestone powder to the cement question? Because we can see that you say if we use more limestone powder, also the very fine ones, the chemical reaction between within the system become better, like this one, can reduce a lot of CS formation. But actually, the risk of diversion also very high. So in the cement test, we should to avoid the generation of this from the previous rock and something else. That's why in the cement industry they don't use too much limestone powder. How about what's your opinion about this one?
Thank you, Professor Phuc. So this is the primary research, and actually we have some equipment to measure the heat of hydration in our laboratory. And I think we actually did it. So we compare the normal heat release from the traditional Portland cement, and we compare it in every percentage of the limestone powder we replace. And then we will evaluate based on the peak of the heat. So we will have two peaks, right? The first peak and the second peak. So we will compare the second peak, and when it reaches the dangerous temperature, for example, over than 80 degrees C, then we will stop there, and we don't replace more than limestone powder.
Yeah, that's why you should consider in terms of using limestone powder in cement test. The other thing is about the workability, as Dr. Di says. Actually, you can use different kinds of like super plasticizer to improve the workability of the picture. It's very simple.
Yeah.
Right? Okay, thank you very much.
Thank you, everyone.
Okay, thank you very much, Dr. Hieu from Central University of Technology. Okay, I'm sorry. Okay, the next one.
Next speaker is Professor Chiu. Professor Yu-Jia Yu-Jia is belong to the same department as mine. He's from Department of Harbor and River Engineering at National Taiwan Ocean University. He belongs to the Division of Water Resource. And his expertise is his research focus on the management of water resource, low impact development, and application of IoT, Internet of Things.
Yes, this one.
And then he will make a very okay, let's welcome Professor Chiu.
Yes. Yeah, thank you very much. Originally, I want to introduce the low impact development because we do a lot in Taiwan. But I think at this time, I have opportunity to introduce the Mekong Delta research because I have a very excellent student from your university, Mr. An. So I want to introduce this one. This is a prediction of riverbank erosion. And I find out it's really very serious problem in Mekong Delta. So I want to introduce this. Okay, next. Next is my content, as an introduction, and the next on the results. Next. Okay. I take the Anjiang province as an example. That's the How River and the Tan River. And I find out this has substantial impacts on the local community resolving the roles of agricultural lands. And when I find the information from the website, I can collect a lot of image of this area, especially for bank erosion. So this time, this should be the challenge to have some research, some study insights. And this mark, the black mark, is the disaster, the bank erosion area. So that's every year, from 2018 to 2022. Next. And here is some photos. I think you have more than me, right? But when I check the internet, this is the serious bank erosion. And I find out the people who live near the river is too close. We maybe have some idea to prevent this kind of disaster. And the erosion resulting, especially some gross square meters of lands, the erosion lands, and still have some property back to $4.2 billion. Okay, next. This is the 2019 still, and then that become more serious because there's some erosion in the band of the river, and like this. And I find out the material along the river is a fine material. I just checked the slides is 0.04 or 0.05 millimeters, the D50. So, and this is the erosion. Next is the 2020. 2020 still. I find the people who live there, maybe the next. Yes, this is asphalt, this is road, still cannot prevent. This, although it's a little bit stronger, but cannot. There's more than $2 billion. Next. Yes, the house is so close, so we will see this photo. And I also find out some district, these An-Phu districts, Cho-Moi, Tri-Dong, Cho-Phu, Tong-Tri, Ho-Dong, Chai-Sam, Dong-Tri, these kind of districts. And the incidents, the erosion, that's a lot. Okay, next. The people who live there, they find out some solution. They use the plastic cover to prevent becoming more serious. There's a plastic cover inside. This a way. Because I find out some photos, the woods, and then some plastic cover. Next. Okay. When I want to deal with this kind of problems, first we have to try to find out where is the reasons to cause this kind of damage. Add factors like the hydraulic and the flow, because the flood, and then some heavy rain precipitation cause the flooding. And the third is about the resource extraction, the same, and the construction of urban development. Some climate change cause the heavy precipitation and the vegetation cover, human activities in the topography and the geology. So I think the property I think that will be solved, so cannot protect well. Next. Okay, I provided this. First, I collect the data, and that's I use the software. It's a HackREST. HackREST model is from the USA. So I use 1D because I want to simulate open river. So it's a hydrodynamic model. And the next step, I use the 2D. I just focus on some interesting area and use the sediment transport model. And I use the real data to calibration and validation. Next. Okay, also collect the data, the secondary and the primary data. Use the ADCP device to measure the cross-section, to know the changes of the cross-section. Okay, next. This is the Syan equation for the hydrodynamic. It's continuity and the momentum equation. And then this is the station I use for calibration and validation. Okay, next. Okay, this is the sediment samples to take the samples to analyze the particle size and the sediment concentration inside. Next. This is the sediment transport. In HackREST model, they use the advection diffusion model, sediment transport equation. Because we have some track sets along the river, so I use the one for the calibration, the other is the verification. Calibration and the validation. Next. Yeah, this is the final difference to solve these equations. For the sediment transport, we have three parts. This is a bed load, suspended load, and washing load. Because our material is fine sand, fine material, clay, sand, and soil. So the particle size is small. So we ignore the bed load part. Just consider the wash load and suspended load. Next. And then this is the sand mining. I have two ideas to describe this. The first, because of the human activities, especially the sand mining. Now per day, that's 50,000 tons per day. So I use this one as the first scenario. The next is climate change. Next, this is the input in the model to try know the phenomena in the river. Next. Because from this scenario, after the calibration and the validation process, I have to use that transfer to the stability of the river. So I use the KAT. That's the slope stability factor to know where is the severe spring erosion area and to find out. Next. Okay, this is the property to have the input for the KAT formula. Next. This is a track set. I use that for the integration to know as the input. Okay, next. This is our result from the calibration and the validation. The Lumen square and then the R square looks like okay for the calibration and the validation. And this is the hydrodynamic result. And next. This is the sediment transport. And yeah, I think we can simulate that nice, but could be better, especially some erosion area. But for our back motion, we focus on the side, right? The side, the river side. Next. Okay, this is the result from the sediment transport model. Because we know the bed change from the river side, and this is around 30 centimeters, 3 or to 10 centimeters. Next. And use KT value to know the difference, like the left side. And from the results, if we do the same mining, our cat value become lower. That means we become unstable. Okay? Next. This is the same mining, so we will find out when we have the more same mining, we have the more difference for the riverside. Next. This is the result. The riverside for the left, we find out it should be okay, but for the right side, that value become small. That means it's unstable. So the cat value is become less, become smaller. When we have a same mining scenario. Next. Our conclusion is that could we stop the mining? No. So we have to do something for alternatives. So my suggestion is maybe we can buy something from other areas, or the bank erosion will become more serious. So this, from our modeling, we will find out this will become this kind of phenomenon. So that's also we provide some management, some techniques that still the idea. But the first idea next is construction idea. Because when I check the Google Earth, I find out our Vietnam governments do a lot. Because the concrete or some stone embankment not being wall, that's by student. And the next, when I check that, this is a little bit change, right? So embankment along the river. So we still do some structure method to prevent the bank erosion. Yeah, that's the nice way. But still, in Taiwan, we still have an experience that the design for failure, because we cannot do everything along the river. So based on the climate change, we have to do some preparation for the design for failure. Okay, so next. This is a non-structural method. This is a disaster protection method. From the modeling, you will know the area which is where the flooding area and some serious bank erosion area. So when we have a prediction from the prediction or expectation, maybe the coming days, or 1 week, 3 days, or 1 day, and we can do some idea to tell the people who live there just run away or just live away to the near river. For the delta, the Mekong Delta, I think when we want to have this kind of map, we have to have a whole picture for this area. In Taiwan, we use the satellite image, air photos, or drone technology to digitize the area and know the disaster influence here. So after that, we construct the digital 3D the map, and later we use the simulation, modeling simulation, to know the influence for everywhere. So that's can give you the time for preparation to prevent the disaster. Okay? The next is the last. Thank you very much.
Okay, thank you, Professor. Is there any question or comment? Okay, Professor actually do a lot of research about the Mekong Delta, and he provides some useful suggestion to connect our experience in Taiwan, especially in Taiwan. Professor did a lot of project from government and help our government to provide many such things, many things such like the disaster potential map or some prevention of disaster. Okay, any question? Okay, if no, let's thank Professor Zhou again.
Thank you very much.
We just have the last one. Welcome Dr. Dinh from the Faculty of Transportation Engineering. We will share us about his research. maybe you should introduce yourself.
Good morning, Professor Professor Giang, Professor Pham, Professor Chiu, and Professor Shih. Everyone here. I'm very honored to be here to present, to introduce about my topic. A little bit about me. I have just finished my PhD program at National University. My advisor is Professor Wang. Before I become go to this program, I'm an officer for the Department of Construction of the Global, and now I'm a lecturer at the university. Now I want to introduce my topic about the modeling of the thermomechanical coupling behavior of the foliated rock, the district and the metal. The content of my presentation have five parts. First one is the introduction. Then I introduce my methodology using the research, and then I show the result of the lab SNT installation. Then we'll do some discussion about the state strain on the TM model. Then I do some conclusion about the result. As you know, in Taiwan, the population of company about in the central mountain range. The potential thermal size are allocated within area characterized the meta of rocks against Chia state. The population of rock cause a lot of problems in the rock HQ. It is tumbling and slope stability. So this I conduct to understand more about the thermal mechanical behavior of the slate. So this is I conduct the drive test on the slate under high temperature and high pressure. And then I will use the display as a method display thermal mechanical coupling behavior of the slate. And in research, we also propose a new model for the magnetic strength quickly. The spaceman using this research is example in the title of Taiwan, where temperature reached 139 Celsius. The slate here have the population from 0 degree to 84 degree. And this parameter of the slate used in this research. The traction test conducts with confined pressure from 5 to 25 megapascal, and the temperature at first I will conduct at normal temperature 25 Celsius degree, then I increase to 100 Celsius degree and 200 Celsius degree. And here is the index apparatus of the digital university. Then here is DC simulation of the state. I conduct the research. This model used to model to simulate behavior of the rock matrix. I use the variable model to simulate the behavior of the rock matrix. And about the correlation plan here, we use the structure model to simulate behavior. And this is the parameter used for the variable model and structure model. These parameters have to calibrate. And this the job distance. Determine the job distance, you have to do the calibration. And after the calibration, my model have appropriate total particle about more than 94,000 particles. Particle size from 1.22 to 2.44 millimeters. And about the use it for model I use the transfer method to get the initial value. And the initial value for the smooth joint model, we use the direct shear test and pull-up test to determine the initial value. Here is the temperature production procedure. This one is the slave model at the normal temperature, and after that I apply the high temperature at the boundary of the specimen, and then gradually increase the temperature 5 Celsius degree for each circle until the slave get the steady state production. And in the BC software, just have the variable model used to simulate the turbo. So here is the turbo particle network, and this is the heat flow in between two particles. Each particle is a reservoir, heat reservoir. This is the result in the laboratory test. If we can see the dark point here is the result at the normal temperature, and the circle, the light circle here is the result of the lab at 100 Celsius degree high temperature. The blue line is the confinement pressure at 5 megapascal, and increase the confinement pressure to 10, 15, 20, and 25 megapascal. As you can see, with the orientation angle from 10 to 40, is the sliding range. The rock strain lowest at the orientation angle equal roughly 38 degree, and get highest strain at 90 degrees. This figure shows the valuation of the state with orientation angle from 0 to 20 degrees. I can get a slight marks penetrate through the foliation. When increase the foliation angle from 20 to 60 degrees, I can get the slide marks, and from 60 degrees to 90 degrees, I can get a slide marks penetrate through the foliation. Result, you can see the temperature, when the temperature raised, just the slave with high orientation angle from 0 to 10, and from 60 to 90 degrees, change reduce. It concludes that the rock magnetic strain significantly reduced with the temperature rise. And the foliation strain not change when we increase the temperature. And when increase the confinement pressure, the strain of the slave almost increase. And here is the result compare between the simulation and lab test. With the different confinement pressure, high confinement pressure, 15 megapascal, 25 megapascal, and when we change the orientation angle, we can see the simulation can reasonably the result of the lab test at normal temperature. So I can conclude that the DC model in our result is reasonably replicate the strain and parallel mechanism of the slide at room temperature. Here is the result of the simulation at high temperature. When the temperature here is 100 Celsius degree. We can see from this figure 12, the peak strain of the BC model nearly fit with the lab test data. with a series of U-sharp curves. The failure method over there are also comparable. And in this result, I propose the thermodegradation function. It also reasonably apply the simulator thermal area of state at high temperature. And in this result, with the temperaure smaller than 200 degrees, I can determine the thermal degradation coefficient equal to 0.112. And sigma C and coefficient here is the tensile strength and coefficient of the linear variable model used to simulate the rock engine. In this model, is simulated for the rock engine of the model. With increasing of the temperature and the fine pressure, this figure shows the three-dimensional diagram explaining the part of the temperature of the strength of the slave model. Through this figure, we can see the rock strength reduced with the temperature, but remain constant when temperature larger than 1 Celsius degree. With the orientation angle equal 30 degrees and 60 degrees, we can see the rock strength almost constant, regardless with the increasing of the temperature. It is governed by the foliation strength. And with the orientation angle, all the orientation angle 0, 90 degrees, especially to orientation angle, we can see the rock strength is strongly reduced. When we increase the temperature, because it's governed by the rock mechanics. When increase and also from this figure we can see when increase the fine pressure, the thermal effect on the strength degradation reduced. So to conclude, this is the conclusion in this research. The elevating temperature can affect the intrinsic properties of the rock material of the slate. The thermal degradation function proposed in this research for the tensile coefficient parameter of the linear variable model reasonable after the temperature effect on the strength and value characteristic of the slate. The proposed model existing a series of U-sharp curves in fixed strength will give the orientation angle under different temperature lasting period experimental height. And the TA model also complete that the high contact pressure reduce the effect of high temperature of bond weakening. And finally, our investigation provides a comprehensive perspective on the effect of temperature, fine pressure, and orientation angle isotropic thermomechanical coupling strength of the state. Thank you for answering. Question about my research topic?
Question for you. How do temperature affect the convection chain across different fluorination angles?
Thank you for your question. You can see when we increase the high temperature, just the slide with the orientation angle from sliding range, not affect to the temperature, but with the orientation out of the sliding range, affect to the
also have a recent thing. Can the proposed DEM model in your study be applied to adopt other rock similar structure? If so, what parameter would need adjustment to make it suitable for rock other than slate?
Yes, of course, the model can be used to simulate all the kinds of rock. When you change the properties of all the rock, in my model, here is the some parameter. We can change the properties of the rock. Because here is a sliding plate, correlation plate. We use the smooth joint model to simulate the behavior of the correlation plate. To get the initial value of this model, we use the direction method to determine the initial value. So when we change our type of rock, we can use the price of the recipe to get the property of the rock matrix, rock strain, the strain of the material of the rock, and for other properties such as the correlation method, we can get the initial value from the direction method, and then to get the initial value, then we do the calibration and get the final parameter for the final model. Thank you.
Thank you for your answer.
Thank you very much for your insightful presentation. So I think Professor Pham, the chairman, should be close this session.
I think we have 6 very wonderful presentation in this section. We should wait for the lesson for the closing ceremony.
Sau cái này xong mình lên mình chụp hình cái hát, rồi xong chắc nhà thầy Giang dẫn qua một cái nghiệm vòng đi trở nên 11:30. Được số mình chút xíu được đi vòng đi trở qua đây phía sau này ăn nghiên chưa ở đây. Okay, we had a group photo. Now bây giờ we take you around and then back here for lunch. Okay. Lên hết đi em.